Hello, 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 and welcome everybody. Hello, and welcome to Cloud Native London Meetup. I hope everybody can join us and feeling fantastic. We have fun. We are December Christmas Cloud Meetup, and let's begin. So, to welcome everybody. Like always, if you would like to join all the people and feel like a real meetup, please go to oishow.com/r and you can join to Rambly, which is virtual chat room. So this is the December, our December meetup. We are happy to have you today. Thank you for finding time and join us. We have our two talks. But first, let's talk about who we are. We are a strong, open, diverse developer community dedicated to the cloud native platform and technologies based in London. However, right now is everything virtual. We are looking to go back to the physical places, but right now, so we are open in everybody can join us from wherever you are. My name is Hubert. I am your host for today. This is my email to Twitter. So this is my Twitter account, so you can find me, and you can always say hi, and we can have a chat. So agenda for today, as I said, will be two speakers. We will be starting in 7:15, and we will be wrapping up 8:15. So first of all, I would like to give the big shout out for our sponsors. So David, if you be so kind and to tell us about the Palo Alto, please.
Thanks very much, Hubert. Yes, Palo Alto Networks, or Prisma Cloud at Palo Alto Networks. I had the opportunity to be at the December meetup 2 years ago. I remember it well. It was in person. So this is a little bit different this December, being virtual. As some of you attended previously in London, we had a good time. So yeah, Prisma Cloud. Well, we get to help customers ensure they're safe throughout the development lifecycle. We principally are looking for things like vulnerabilities and dependencies. We are looking at things like Kubernetes app YAML files, looking for misconfigurations, and ultimately it's about keeping our customers safe. And so yeah, we do that day in, day out, and it's a lot of fun. So yeah, all things security, of course, if you know a bit about Palo Alto Networks, but principally Prisma Cloud. It's all about cloud native security. Thanks.
All right. Thank you very much, David. If you need a security, well, you know where to hit. David, it's a good place to start. And for Humio, we have today Afran. If you be so kind and tell us a little bit about the Humio.
Of course. Hi, everyone. Afran Sharif. So this is my first cloud meetup for Cloud Native London. So Humio proudly sponsors this, and Humio itself, it's a time series log aggregation platform, and it allows our customers to work with real-time data from their environments, regardless of whether the data comes from cloud or on-premise. Humio also works across a number of use cases. So we work with data across IT, security, and business analytics. And yeah, I'm looking forward to the rest of this session and watching some of the presentations today.
Thank you very much. So next will be Zan, unfortunately from the Circle CI can't join us today. So let me give a shout to Circle. Circle CI, the world's best software teams use CI to deliver quality code with the confidence. The largest CI/CD platform, CI/CD empowers engineers to seamlessly take ideas to execution at scale. Every feature is on our platform is built to fine-tune and entire development process from start to finish. If you're looking for CI, Circle CI, it is something what you will be probably happy with. And NetApp unlocks the best of the cloud so that you put your data to work in applications that run your business. It is called building the data fabric, and you are good in the good company. And our sponsor for today, Ondat. However, I think that we will get a little bit more about them later, as we have someone who will be speaking. So the next step we'll be talking about we would like to know who you are, people in the audience. So here on the screen, you see a link. Please go there. Or if you watch on the YouTube, there will be link in the description. You can join. And we have a few questions about you, about from where you are, and a few questions from our speakers today. So orishero.com/p, you go there and you will get, and we will be there will be a few very simple questions what we would like to hear from you. So orishero.com/p. I hope everybody get that. So I think we can start. First question is your first time in the cloud native. So is good icebreaker. And I think that we will see how everything looks like today. Usually we have a 50-50, but this is always very, very exciting. If there's so in the meantime, I think that our speakers, I think they mentioned that first time today. Give people to join, maybe, and see everything works. All right. And okay, but hopefully we have a strong no. Can we have more? Maybe I will remind you. It's a link to is on. If you watch us on the YouTube, give a thumbs up, subscribe, and don't forget the bell icon if you would like to hear from about the next meeting. And if you want to join the poll, there is a below there is a link to there's a link to the poll so you can join and give us our answer so we will know a little bit about you. Now everybody we have a strong 100%. Everybody is who joining today are returning. Okay, I think we can move forward then. So, can you let us know where are you now? Also, we have a strong Great Britain representation. Oh, I think this is someone north of the Spain. So nice. So as I said, this is a visual meetup. So wherever you coming from us, welcome. Glad that you join us today. then let's give the people a little bit more time, maybe some little bit more. So please don't be shy, everyone. But I think we can move. All right, so can you let us know what's your job title? What is the best from this one? What it's listed here? Which one is the best? What suits you? And if you are there, I would like to hear, because we can update the list in the future. So we'll see. Oh, that's interesting. SRE DevOps engineers. Okay. That's usually, I think we have more architects and the backend developers, but this time SRE DevOps engineers. Okay. But now say security engineers this time. Let's give a few minutes. Oh, wow. All right, this is strong. 50-50. Okay, all right, cool. Little bit more. Someone else would like to join? Let's give a few seconds extra. All right, let's move to the next one. And this is a question from our speaker. Are you running stateful workloads in production? Yes, no, I'm considering. So that's the controversial topic, to be honest, hopefully we will get a little bit more answers here. We have a 50-50. Okay, that's interesting. So what you're expecting? Do you expect this result?
Is that a question for me?
Yes.
Yes, that's right. Yeah, definitely. A good chunk of people considering, and some people already running.
Oh, so I'm surprised that there is no like a strong opinion. No.
Yeah.
All right. So okay, I think we can move to the next question. Let's give a few seconds. No. All righty. So, have you used any tools to benchmark your Kubernetes cluster before? No. Yes. KBench. Yes. KubeBench. Yes. VMWare. Oh my, that's the tongue twister. VMWare. I think yes. KubeStar, KubeMonkey, or other. And I think that the other will be very interesting to hear. So Dan, I think this is the question for you. What are you expecting?
Yeah, so quite interested really to hear people's responses and experiences, especially after my talk later on, because realistically what I'm going to be talking about today is just what I found trying to research in the community and find out what people are doing, and actually, you know, understanding how to benchmark and performance and design Kubernetes is it's still a changing landscape today. So not everyone is kind of doing that. You know, I find some people have just jumped straight in, built a number of nodes, and they just keep adding more nodes when they kind of run out of performance, right? And they kind of don't understand how to benchmark, for example. So one for KubeMonkeys, that's quite interesting. So KubeMonkeys based on the premise of Chaos Monkey from Netflix. So that's kind of a cool option out there.
Okay. All righty. Yes. So I think we are perfect on time. I will. So next talk will be how to optimize and scale cloud native application storage. So I stop sharing. I think that Rodney, time for you to shine.
Cool. Thank you for the introduction. Let me just share my screen first before we move along.
Yes, please.
Share my screen. And can you see my screen? Can everybody see my screen?
Yeah, I see your screen perfectly.
Okay, Fantastic, great. Thank you. Good afternoon, good evening, good morning for people who weren't able to do the polls. My name is Rodney, and I joined Ondat about a month ago, and essentially I am a customer solutions architect at Ondat, and I work in the customer service team, and I help customers solve a lot of the challenges around storage and essentially and helping them scale, storage too. And today we're going to be speaking about a couple of these topics here: understanding the storage silo and creating a storage optimized Kubernetes cluster. And we're going to go into a live demo. Hopefully, the demo gods are going to be with me today to install Ondat, to deploy some stable workloads. And of course, provide some example workloads of encrypted, showing encryption, replication, and performant persistent volumes in applications. And just to dive into the topic, developer-centric storage. So we generally see that there are two personas that we generally see when it comes to dealing with storage, and we have the development team and the platform owners. And as a developer, you want to be able to request storage easily. One of the things also is to be able to have storage available quickly. I think one of the most important things when you're developing applications, you want to make sure that the storage is performant, so that storage isn't the bottleneck for your application. I think, of course, another main thing, it should be easy for developers to be able to enable encryption, replication, fault tolerance for the applications. It should be on demand, and just really, really easy for people to adopt. And then, of course, the other side, we have the platform engineers, the SRE teams, the infra team, and one of the main things is that they are, for them, what matters to them is having highly resilient and reliable storage. This is important in production. You don't want your data to fall apart, and this is key. And of course, the second thing is that, okay, we've got reliable data, we've got reliable storage, but how are we gonna give this to our developers so they can use this easily without opening up tickets left, right, and center for me to request storage for them? And this should be an easy self-serve storage solution using the Kubernetes API. So it should be really simple for developers to be able to enable this and help platform engineers to maintain and support this. Another thing which is quite important, SREs is having the observability and metrics for predictive capacity planning, alerting, and also debugging. You want to know what goes wrong and why it went wrong when something breaks. And you want to be able to see if your storage consumption is increasing over time as you grow. If you have more data, you're probably likely going to need more storage, but you want to make sure you plan for that. And that's, I think, that's quite important. And lastly, I think for platform owners, they want to be able to have operational flexibility, such as volume placement. And these are a couple of the key things we see when it comes to managing, data is, you have this silo where, hey, this is storage, let me forget about this, then you have another storage silo and you end up having 5 or 6 different storage silos, and it becomes very difficult and very expensive to, manage over time. What does a developer expect? Just running a quick test on the laptop, we get this count of IOPS, and this is just on average on a modern ThinkPad laptop. I forgot the version that we're running on, but essentially, what the point is that software is generally developed and tested, on laptops first, or workstations, depending on when the individual is. And in the past, we used to have spinning disks that were slow, but that was the past. But nowadays, you're generally going to expect, an NVMe storage device, or even just a standard SSD device, which is going to reach up to 850,000 IOPS, right? That's 850 IOPS per gigabyte, and that's something that that you end up realizing developers are creating applications and using these requirements, and they expect this or better when they essentially are going to be shipping this to production in the cloud. And if we compare, of course, different AWS devices compared to Intel devices, you can see that each device has different performance and different speeds. And you might find yourself having a cluster that has block devices attached to each other, to each node, sorry, and they all have different IHOPs. And how do we aggregate all these IOPS, and how do we make this available to be performant and consistent at the same time? And that's something that is that needs to be solved, and it's really difficult, because I think you can imagine long term, as data grows, you can imagine things get more costly, and you want to make sure that you're able to be effective and using most of your storage effectively that is available on your nodes. And to still focus on the developer-centered aspect here is that we're talking about this should be easy for the platform team to be able to give this to developers, and this is possible using Kubernetes labels. This should be possible, and it should be really simple by just adding a flag there and say, hey, we have a persistent volume claim, and we want a developer to say, hey, you know what, I want to test out to make sure I've got one replica, and I have encryption enabled for my volume, and I have topology awareness. So that means that distributing our volumes between for our nodes in different availability zones, and this should be pretty easy, and it is easy to be able to do this. Now, to DevOps and platform-centric storage. Now, we were talking early on about the Kubernetes labels and leveraging that, but also you can also do this using the storage class to manage storage. One of the things is essentially you find yourself as a platform engineer, you might find yourself in a situation where you want to say, hey, this is a production instance. I want everything to be having two replicas, encryption always enabled, and we have topology awareness enabled, and I don't want a developer to not have this for the application. And you can do this using storage class. You can make your own custom storage class, and you can make your environment much more predictable. And I think that makes it a bit more easier. And you can always have that in your mind, like, hey, you know what? I know everything that's in production has met these requirements because we are only allowing our engineers to use the storage class for their stateful workloads. So this is some of the ideas that you can get out from using parameters and values when you want to leverage storage in your environments. Creating a storage optimized Kubernetes cluster. So we've already created a Kubernetes cluster using EKSCTL. I'm sure some of you may be familiar with this, but if not, it is essentially a provisioning tool made by the awesome folks at VMWare, and essentially it allows you to create a cluster and quickly, well, not quickly, compared to before the internet or before cloud iteration, I think 20-25 minutes is pretty much okay. But we've already created a cluster because this will be the whole call, waiting for a cluster and watching the terminal just indicate that it's still creating something. So so we've already created that, but we're going to move to the next stage for storage abstraction. And this is where I'm going to stop sharing my screen and going to switch to my terminal and share my screen again. And hopefully the demo gods will be in my favor and would have sprinkled some unicorn dust on my keyboard for my environment. Let me just see my screen here. Let me actually minimize that instead, or just put that to a different window. I hope everybody can see my screen. Okay, cool. All right. Okay, cool. So keep cuddle, get pods, all spaces. So we have our cluster up and running. That's good. And we want to deploy Ondat. And before we do that, we want to make sure that we check that storage OS help. That we've got the command, the plugin tool that we use, which is open source, and it is available to use and deploy, and it's available in our path. And the next thing we want to do, you want to run a pre-flight check. Storage OS pre-flights against our cluster. This is going to run a couple of checks to make sure that it meets the requirements for our environment, so that we can install Ondat. As we do require some, as Ondat does require some key kernel modules for us to be able to work effectively in a cluster. And yes, we can see, I'll demonstrate what those are just now. And we've got at least 4 gigs of RAM. We've got at least one machine running Linux, of course. Required Kubernetes version, it meets the requirements. The container runtime, we have Docker enabled, and we have at least 3 clusters running the cluster. And you can see here it's saying that, hey, you don't have enough, you don't have an NVMe storage, but that's okay because we're just using a GP2 EBS volume instead. And you can see the kernel modules I was talking about earlier on. These are key for Ondat to be deployed successfully and work effectively. And this is key for them to be available on each operating system, node operating system. And yeah, so let's quit this. And the next step is to install Ondat using one command. And before I press enter, I'm just going to go over what is happening here. So we can see that we are including etcd. Ondat has its own etcd instance that it runs. Of course, each etcd instance is going to need its own storage class, but in this situation, I'm going to use GPT-2 just to get our etcd instance up and running. Admin is our username, and password, you would want to add a strong password and not add a strong password here. And of course, we're just going to use 2.5.0 beta 7 as 2.5.0 should be coming out soon, GA. If you press enter, if I did press enter, let's hope I press enter. And yes, I can see my cursor is flickering there. And it should take about 1 minute or so, 1 or 2 minutes, depending on everything working. And yeah, so we can see namespaces being created. And yep, we just creating some resources for etcd. We've got our role-based access control permissions there that have been created. And yep, the operators has been created too, and you can see that we are almost there in terms of getting our environment up and running. Great, fantastic. So I guess that's the hard part done. Let's see if our pods are up and running. So yeah, we're gonna have to wait for probably a couple of seconds. It should take about just under 1 minute for everything to come up as everything's being initialized and some containers being created. But as you can see, we've got, this is a daemon set here, and we've got an operator here that takes care of, Ondat. And you may see storage always being referenced here. On that sort of reference, this will be something I may change it changingly, but it is the same thing. And, one more check. So yes, we've just got our daemon set that is initializing right now, and we should be almost there. One more container that should be up and running. All right. Almost there, and it looks like we have a couple of other containers that need to come up, and 3 more left for our CSI helper. Perfect, fantastic. Get pods, get SC, and you can see here that we've automatically installed our own CSI here for Ondat. So if you do kubectl describe SC, this shows all the SCs, but that's okay. You can see, of course, some of the parameters there which are enabled. This is just to use exe4 as a file system. But of course, everything else is just to keep it very simple, because we leave it up to engineers and platform engineers to decide what they want to do and create their own custom configurations. Now, in my test here, I am going to go into my storage classes. And we can see that we've got about 3 storage classes here, but I'm going to pick one here just to save time. We're going to cat v2, and then we're going to do encrypted and topology awareness. And you can see here that we have a couple of labels that have been enabled, parameters specifically. And you can see that we've got replicas 2 that is enabled. That means that we'll have 2 replicas for each volume. We have encryption enabled for each volume, and we also have topology awareness placement enabled too. So this is going to give us fault tolerance. This is going to give us encryption and replication for any workloads that we decide to use. And this is pretty easy, right? You know, it should be easy to deploy. And to verify, we can just do a kubectl apply -f, and that should curse through everything. And kubectl get sc. You can see, of course, we've got that up and running, and that's fantastic. And yes, so before I move forward, I'm going to change the default. You can see that right now GP2 is the default CSI, but I want to change that to use storage OS rep enc tap, and I'm gonna just disable that. And if you do SC again, you can see that nothing exists anymore. And if we enable that, and voila, and we do SC again, you can see that we have our storage OS with replication, encryption, and topology awareness enabled. This means that any persistent volume claims that are created are going to use this. Are going to use this as the default CSI. So hence I'll talk about the platform specific centric storage solution that, hey, you can make sure you can enforce this if you're using OPA or Gatekeeper. So you just know that your environment has all these features enabled. And if we now go back into my other directory, go to PC, and you can see we have a couple of manifests here. I'm going to do cat 04, and we're going to do cat 8, if I can type. And yeah, so just to talk about the CSI I enabled early on and the other ones, you can see as a developer that I can also enable this using, persistent volume claim if I want one replica, or essentially, and then once that's done, I can essentially just say, hey, I can call this to a persistent volume claim and, just deploy this. This is just a simple BusyBox image. The purpose of this demo is to demonstrate that, hey, you can have these persistent volume claims enabled and allow your pods to run successively. So I should be able to do the same thing I did by -f earlier on for the storage classes, and that may take about under 1 minute to get pods, all namespaces, watch, and we're going to wait for the pods in our default namespace to come up. And it looks like everything is happy. Again, yeah, 1 out of 1. So that's great. But hey, we want to be able to see, we talked earlier on about visibility and having some observability that, hey, you might find yourself not giving kubectl to your engineers in production. But hey, you want to see that, this is actually available and it's running in the environment. What we can do here, we can say, Control C actually, if you do that, I'm trying to use my history here, port forward. We're going to port forward our UI that is on this deployment. And it's going to port forward to my local host here at port 575, local host here. And I'm going to push it here instead. Now, I hope I do remember my password. So admin, add strong password. Yeah, I think I might type that incorrectly. Yes, I did, but that is absolutely fine as I do have this here. Brilliant. So let's refresh that. Looks like I might have done something incorrectly here. There we go. Perfect. Cool. Looks like there was just a session refresh there. And you can see here that you can log into the UI and you're able to see that we have volumes here. And these volumes, as we talked about earlier on, that, hey, you can define what your volume would do with these by using labels. These are all of our pods that we deployed earlier on. And if we go into a volume here, we can see that we've got a volume ID here, and you can see it's attached on this node. And we can also see that we've got a master one, which is also going to be attached on the same node because we just only have one replica. But the most interesting part, because we've got topology awareness placement enabled, is that Ondat intelligently figures out that, hey, I need to put this in a different node in a different availability zone. And you can see that the IP address here is different. And that means that we've got a different copy of this in a different node. And this is achieved, using otherwise, if you create your clusters using regional clusters in GKE or EKS, you put a node in each availability zone. That means, of course, your data will be evenly distributed and it will give you a lot of, fault tolerance and a lot of reliability. So if this does get compromised, on that intentionally, hey, we're gonna have to revert to the other replica, and that's safe, and we can assume that that node is there and it's available. You can have more than one replica there. You can have two, I believe it's up to 5, but of course you would have to consider in terms of latency and the performance of that, how many nodes. It all comes down to capacity planning in the long run. But yes, this is the UI, and yeah, and that is pretty much it. That's a quick demo. Let me just Control C that, and let me see, I've got about 7 minutes left. So get nodes, grep for the zones, and you can see that my nodes, if I can type correctly, get nodes. Am I doing this correctly or not? All right. I describe, my apologies there, describe nodes, rep zones. And this should work. Yeah, much better. Cool. All right. And you can see, of course, each node is in a different zone. We've got E central 1, E central 1A, E central 1B. And if you have 2 or 3 nodes, it's all going to be evenly distributed by simply enabling a flag or a parameter in your manifests. And yes, and that is the demo. Fortunately, I think it kind of went okay. But if I share my screen back to the demonstration, all right, and I go back. So this is, of course, what I just went through earlier on. This is make sure, just in case things fail, I will have something to be able to show to everybody how things work. And we talked about the stateful workloads that we configured earlier on. And of course, the visibility, just I think, some points there are useful. You can see, of course, you have the encryption enabled there, the replicas, and the topology awareness there. And of course, if you have more replicas, you're going to have them distributed in different availability zones for each node. And conclusions. So the goal this year is you want to be able to virtualize and pool your clusters block storage to get the right performance with the right pod. Being able to do that, by pooling all your IOPS and aggregating them into one pool, it makes things much more easier to maintain and manage. And probably the second thing, of course, is you want to make sure that storage, you make your storage developer centric and use Kubernetes labels and parameters to create an easy to use self-serve solution. And I think these are one of the things where, we find ourselves being slowed down because we're waiting for resources, we're waiting for requirements, and this is not the cloud native way of doing things. We want to move quickly. We want to deliver software quickly, and this is quite important. Fast storage connectivity is also another key thing that we want to achieve. And work around any block device limitations. And of course, you begin to get creative now and think about the cost optimization that you could think about in your cluster. I was going to do a demonstration about running Postgres and running 10 databases on one cluster. But of course, we have almost run out of time. But that it opens up a lot of possibilities, right? A lot of possibilities to make your not just your containers, but also your stateful workloads dense too, and get the most out of your Kubernetes clusters. And yeah, if you're interested, you can check out Ondat. And you can also check out the demo repository that I used for this. My colleague, Chris, he's my awesome colleague. He's not feeling too well today. He's got COVID, but he's doing fine right now. So I came in this week to, work on this and, hopefully it went well. And thank you. I'll be here around to take questions, and also just to say we are hiring too. So if you're interested in working on solving hard issues in distributed storage solutions, and feel free to get in touch with us. And yes, that's pretty much it.
Right. Thank you very much, Rodney. If you be so kind and let me share my screen and let's see. So this is our polls. So if you have any questions to Rodney, please, let's see if the high quality technology will work. And so this, you can use the link which is on top of it, or you can try to use the link what I just posted. Good question. So waiting for all right, well, look, there's already a question for you. So
Yes.
where can find information for testing?
Testing, you can find this information here on Ondat.io, but there was a link that I provided early on there, just at the end of the presentation. It's Chris Milstead /SA / Ondat demo. But we do have plenty of information on our website, and we also have our GitHub repository. Also, there's also information, and feel free to reach out to us. Yes, absolutely. docs.ondat.io. You can get that information there. It is open, so anybody can, go there and read. There's no need to sign. And I think we believe in making sure this is information that is out there to educate people and make sure everybody is learning too, because we're all figuring things out.
All right, and can you tell me in the meantime, when we wait, maybe there's one more. Hey, there's another question.
Yes, absolutely. Can I deploy a database on that volume? Yes, and I think this is one of the main things Ondat is trying to solve or has solved. And not just one database, but many databases. And you can have databases that are of different types, right? Of course, if you have many volumes, so you're not just stuck with Postgres. You can run any other version that you want to run, any other version or type of database you want to run. Does Ondat support container runtimes? Yes. If I understand correctly, I actually was doing some testing on GKE the other day with containerd. I haven't tested out Creo, but I believe we should support that. I saw that in the documentation. So yes. Can I find testing?
There is a lot. There is a lot, and so thank you very much for Renee. If you want to, you can join us on Rambly. So is exactly same address. Just let me do the technology /. If you want to join, if you have any questions, go there to hang up with the rest of the guys. Probably there is more questions because running stateful systems, it is one of the very hot topics, but I think this is very interesting, and you will find much more questions. So if you would want to, you can join the Rambly and to chat with the people. But now let's give a stage to Dan. So Dan.
Thank you.
Thank you very much. Hello, everyone. Thank you for joining us today. My name is Dean Lewis. I'm a cloud solutions architect working for VMware, and the session that I submitted for the Cloud Native London event was to look at the basics performance testing, benchmarking, understanding your Kubernetes platform and workload. And I've kind of been working through this for probably the best part of 6 months now, and still kind of developing and going on. Although I actually work for VMware, this is more of a kind of community-driven session that I've been working towards for quite a while as well. I've just put it into our corporate deck because it was nice and easy for me when I first started to present this. So a little bit about me, you can find me blogging at theeducate.co.uk. If you want to interact with me after today's session, you can get in touch with me on Twitter at SaintDLE. And we're going to go through a couple of different areas. So we're going to look at infrastructure, we're going to talk about a little bit of platform, design decisions, cloud native storage, networking, resource management, scaling. Of course, because I do work at VMware and that is my life, it is going to be more heavily focused towards virtualization and therefore VMware platforms. We're going to talk about the tools that are out there to help you understand benchmarking and how to get the metrics and data for yourself, and then if we have time at the end, before we hit the half-an-hour mark, we'll look at a live demo as well. I've got a couple of different tools to actually show you in my lab environment. Okay, so when we think about running Kubernetes on a virtual environment, it's just virtual machines, right? So who cares? Let's just install the virtual machines, give it some memory, give it some CPU, potentially some storage, and install our various services, and away we go. And it's not quite that. So the first thing we need to think of is obviously what the platform is that we're running it on, and how we're actually surfacing those resources itself. So again, obviously some of these considerations that we talk about today will actually work in the bare metal world as well, but we won't kind of dive into kind of bare metal design for today's needs. But the first thing to think of is the compute. So are you going to place your virtual Kubernetes node side by side with other mixed workloads, whether they're dedicated database servers, application servers, or other? Are you going to use features such as resource pools? So resource pools are a way to ensure that you've got different tiering of those compute resources when you've got contention in your environment. Or are you going to use something like limits? Typically in any virtual environment, limits are a really bad idea. They're misunderstood, they're misconfigured, and they're a great source of finding constraints and problems in the environment, especially when they've been set and forgot about. And also think about anti-infinity rules. So virtual environments are great because you can deploy lots of little virtual machines and consume all of those resources in your virtual cluster environment. But we don't want these virtual machines all living on this same host here. We want them to be spread across the environment as well. So do we need to use additional rules in our environment to span that across? Then thinking about storage. So what storage are you going to use? How was that storage scoped? Many customers that I speak to, they typically will go with using existing storage in their environment that again is shared. And then maybe they'll bring in dedicated storage in the future, depending on the needs for their application developers, their container environments and services and so forth. And then finally, networking. So how do virtual machines communicate with one another? How do they go across the network? Do they go virtual machines across disparate data centers or clusters? And are you going to implement any quality of service as well? So these kind of questions that you need to ask yourself up front, and really about using your existing infrastructure before you even start to deploy Kubernetes into your environment. If we start to dive down into some of these areas, so cloud native storage is kind of one of the big ones. If you've been using Kubernetes on a VMware or a virtualization environment for, the past 5 years, especially 5 years ago, storage options were really limited. So you build your container and run it, and if you did need to save your data and make it persistent somewhere, your options are kind of limited. So you maybe be looking at something like an in-tree driver that maybe connects to an NFS volume somewhere. And that was kind of great. You could bring your own SAN and bring your own array into your Kubernetes environment, but you'd be bypassing maybe some of the goodness or some of the configurations of your underlying platform, especially in the virtualization environment. Now, as time's moved on, we've made it really easy through the out-of-tree drivers, the CSI, so that you can deploy a cloud-native storage control plane running your Kubernetes environment. That then will transpose it across into the underlying storage that is part of your VMware or virtualization estate. So you can take advantage of that storage that already exists there. So within VMware, we also have a scale-out storage called vSAN. That means it's built into the hosts, so you don't need to have an external SAN as well. We can interface with the management plane, and then we can surface that underlying block or file storage as well. And what we can also do is we can take all of those storage policies, so different I/O ratings, all flash, hybrid storage, encryption, for example, different protection methods in terms of failures to tolerate and RAID settings and all the rest of it, that are set at the virtualization layer, and transpose them into a storage class as well. Mean that when your application developer or Kubernetes operator comes along and deploys maybe MySQL and says, hey, I need a PVC links to a storage class here to give me some persistent volumes, it's going to transpose that back to the storage policies that are available within the VMware environment. And then you can consume that underlying VMware storage as well. And that's all done dynamic as well for you, rather than having your virtualization admin having to understand the Kubernetes platform and statically start creating things as well, which is obviously one of the powerful things of Kubernetes. One of the reasons why you're trying to use it is Kubernetes at the end of the day gives you that rationalization of bringing infrastructure together, and you can call it all through a central API control plane. If we then start to dig down into the more complicated areas such as networking, so the question we need to ask ourselves is, what network plugins are we using? So what CNIs, for example? Because CNI has to be set when you bootstrap and deploy your cluster. It's not something that you can easily replace in a live production or development cluster that's out there in the wild. Think about how your pods are going to communicate with one another. So pod-to-pod communication, and again, is this going to be on the same node? A pod's going to be running on different nodes because, again, you're running that scale-out architecture, and those pods have to communicate across nodes even though they're in the same namespace. Are they backed by some sort of service? And that also includes the external to internal communication to these pods. Are they going through some sort of ingress service? Or have you introduced load balancing into the environment as well? If the pods aren't local to one another, so they're across different nodes. Again, we think about those virtual machines and their placements. Do they have to communicate across virtualization hosts in your environment? And then again, at a networking layer, how are we actually accessing storage? If we're not going to use the underlying storage of the virtualization environment, so we're going to bring our own storage into the environment. Maybe we're using an NFS provisioner, maybe we're using some sort of S3 object storage as well. And again, that could be back to a physical array that offers that type of protocol. We're then going across the network to access all of those. So again, we kind of think about what's going on inside of our Kubernetes cluster, and then we kind of look at what happens outside of it from a storage point of view as well. So where do we sit? And then we have to think about our underlying physical network all of a sudden. So do we need to increase MTU sizes? How many hops between our environments as well? Typically, if these are going to be within the same virtualization cluster in the same data center, the hops are going to be relatively low. But if you have a scale-out architecture or going between data centers for whatever reason as well, or having something such as a metro cluster or a stretch cluster, then those hops again could start to build up, and more hops in the networking world typically also brings more latency as well to consider. And the networking point is probably really key as well, because there's a plethora of options out there. And again, you kind of need to make that decision up front. And so to give you an idea, just from a VMware point of view, we've put together this little bit of a table to kind of think about some of the different networking options. So the table at the top here, we've got 3 of our consumption methods of our own Kubernetes platform itself. So we've got vSphere with Tanzu, so that's just taking the normal deployment of our virtualization platform and then having an integrated version of our Kubernetes runtime. We have a full software-defined data center release, which is called a VMware Cloud Foundation. And then finally, we have that same Kubernetes runtime, but you can also run that in the multi-cloud, so things like AWS, Azure, and that's our multi-cloud offering. So from a pod-to-pod networking, we can use the open source Andrea or Calico CNIs. If it comes to our software-defined data center, we give you that out of the box. We use this software-defined networking layer, a virtualization layer called NSX. And then again, if we go to the multi-cloud world, it can be the same. And then as we start to go through that for node networking, and again, we can use our internal virtualization network, and we can use the software-defined networking of NSX. Load balancing, so we obviously need load balancing for the Kubernetes API. Load balancing for pods, and again, for some of these areas, load balancing and using ingress as well, you may have to bring separate controllers in there as well. And then finally, maybe you're looking at getting smarter in terms of your networking as well, and providing the ability to microsegmentation between pod-to-pod communication as well, which is something that's not quite easily achieved or not typically available with the out-of-the-box providers as well. So you've got a number of options there as well. So from VMware, we typically stick with our stalwart product, which is NSXT, to help provide that as well. And then if we go back to one of the other areas that I mentioned before on the last slide, so if you think about MTU, that's also quite important as well, because each of these options support different features, different functions. And that's not only a feature set from things like being able to do pod-to-pod micro segmentation, but also their configurations as well. So if you in your environment are going to have highly transactional workloads, and you do need to increase the MTU size for whatever reason, then maybe you're looking at something like Andrea, which supports that, whereas Calico doesn't. So there's quite a lot of considerations from that point of view. Okay, so I've kind of thrown a few options at you there, just kind of considering the general infrastructure piece. And the reason why I started off with that is because when I'm speaking with a lot of my customers, their typical getting started in the cloud native journey is obviously to use their existing platforms. So the infrastructure kind of already exists in the environment. So it's a case of, well, we're going to use our existing infrastructure for the time being. And then we're obviously going to think about what that looks like as the environment grows and as our cloud native platform starts to mature or go into production as well. So now kind of let's take a step back and then start to think about some design decisions. And this isn't a detailed list. As I say, this is kind of some of the things that I've discussed with customers and thought about myself. And it's kind of really hard to actually get a nailed on answer to people out there about designing Kubernetes environments, because everyone's kind of opinion is slightly different, and it depends again what you're doing as well. Whereas obviously with virtualization, it's been around for many years. So virtualization, you can pretty much, search for blog posts. There's books that have been wrote about it. There's reference architecture and so forth. But yeah, so let's start off with the virtualization layer. So the great thing is if you have worked with virtualization environments, which I think pretty much most people in IT have done now, thanks to prevalence virtualization, it's just like you've done before. You need to think about your underlying configuration of your virtualization environment. The basics such as setting security access, setting NTP for logs. We need to think about our storage, so the read and write speeds from the hosts, the underlying storage that you're going to bring to that. Do you need to use multipathing? Is there a certain multipathing software or plugin that you need to install? And then again, if you're going to use that storage to be passed through into the Kubernetes layer, is there an additional software that you need to bring, or configuration or firmware versions, for example? So let's think about maybe pick on HP, for example. HPE have CSI drivers to use their storage arrays in a Kubernetes environment. Again, think about the networking for the virtualization layer. So the network cards, are you going to be using 10 gig, 25 gig, 40 gig, 100 gig? How are you setting up those network adapters themselves? You can have dedicated network adapters for the management traffic of your virtualization environment that separates it from the virtual machines. Do you want to have separate physical adapters that are going to be used for virtual machines for cloud native, so your Kubernetes environment, versus the rest of the workloads if you're sharing those workloads on the same host? And that comes to the last point there, which is the cluster usage as well. You can drive more value for the money that you've paid for your system by obviously mixing workloads on your environment rather than having separate silos of virtualization hosts and clusters that are running dedicated workloads themselves. But again, those come with different performance needs and may have a knock-on effect or become noisy neighbors to one another as well. And then let's start thinking about the Kubernetes clusters themselves. So the virtual machine resources, how big are they going to be? What are you going to go through a particular t-shirt size, or are you going to start off small and grow it? Check NUMA. So when you're on a virtualization environment, obviously those requests from a virtual machine are being transposed down to the physical hardware as well. So if you have lots of virtual machines at 2 CPUs and 4 gig of RAM, that's going to be translated into cycles through the kernel layer of the virtualization host to the physical hardware. And actually that's going to be mapped down to the configuration of that hardware as well. So think about what memory channels that you're using, how that relates to CPU. Now, typically, most of the time, NUMA doesn't really come into it until you've got really high performance workload. But again, you need to set yourself up for success and think about this up front rather than something that you have to re-architect in the future as well. And if you're using VMware platforms, there's a number of great blog posts and reference architecture that go into deep dive about NUMA and virtual machine resource design as well before you get going on there. And thinking about big virtual machines versus small virtual machines. So your Kubernetes cluster itself, are you going to have a limited number of virtual machines that have got 16, 24, 38 cores in there, and you're going to load it full of RAM, 24 gig, 56, 64 or beyond? Or are you going to actually distribute that out further? So maybe you'll go for 10 virtual machines and you're going to only put 12 cores in each virtual machine and 24 gig of RAM in there. And typically that will also then come down to the applications that you're running there. Thinking about pod limits, you can only run 110 pods per node. And again, coming back to anti-affinity rules, where we have to ensure that our virtual machines are distributed across our cluster. One of the great things in a virtualization environment is if the underlying host dies, your cluster should power on that virtual machine elsewhere in the environment, which is brilliant. But again, you want to make sure that it keeps those virtual machines spread apart where possible. And then we get to one of the other important areas, so the application layer. So think about how are you going to actually deploy the applications, what the application developer is going to be consuming, what's their access into the system. Will you let the Kubernetes system decide how to best manage resources? Are you going to set resource limits on pods and containers, which is nowadays considered a best practice? Are you going to use selectors the placement logics of pods and containers? Or are you just going to say, hey, run this pod in my cluster and find the best place for it? Because again, that's going to come back down to things like, where are those virtual machines placed? Are you going to create fault domains in your racks, for example, which then transpose to the physical hardware? If you've got 8 virtualization hosts in your cluster, you might have 4 hosts in one cluster, 4 hosts in another, 4 hosts in one rack of your cluster, the other 4 hosts from your cluster in a second rack just for fault domains. Then you ensure that in your Kubernetes cluster, you've got your nodes evenly split between those 2 sets of 4, which means you're in 2 separate racks if one rack fails. And then again, you need to think about that for when you deploy your applications as well, to ensure that your pods use the right selectors so that they have that distribution as well. If you don't have that set up, who knows, Kubernetes might just put all those pods running on the 4 hosts which sit in one rack. And then future planning. So how will you scale? Is this going to be a manual process? Is it going to be automatic? Think about how you're going to scale pods. How are you going to scale up or scale out? So increasing the virtual machine resources. So the more smaller virtual machines that you have, at some point you're probably going to need to add more resources. You're going to add more resources to the virtual machine. You're going to add more virtual machines, which will be scale out instead. Okay, so moving on and thinking about monitoring, because actually monitoring is a really key part of this. How do we get the metrics and counters and information data to actually make some decisions, either when we're doing this in testing or once we've gone out into production and we need to make sure we're working towards a baseline? So the first thing to think about is infrastructure up. How do I know that my virtualization platform is offering the right amount of resources and performance to my cloud native platform itself? So if it's a VMware environment, VMware has operated been a stalwart program for VMware for many years to understand and run your virtualization platform. We actually have the ability to connect into a Kubernetes environment as well and understand that Kubernetes environment in depth. We won't give you metrics from inside your containers, but we will give you metrics inside of the Kubernetes environment itself. Actually, that slide's slightly out of date now, because one of the things that we've done is to extend it even further so that we can pull data using the Kubernetes Telegraph agent as well. So we can now get container metrics as well. Alternatively, you could use an open source product like Prometheus. It's very extensible. We'll give you metrics both in virtualization and container environment, which doesn't kind of pull these together and kind of create that relationship of context for you. You're going to have separate metrics in separate graphs. So that makes it a little bit harder to troubleshoot and kind of correlate that data. And again, with Prometheus, where are you going to deploy that? It's going to be inside of your Kubernetes cluster. So it's actually eating resources of your Kubernetes cluster away from your application. You're going to deploy that outside of the Kubernetes cluster. And again, is that going to sit as virtual machines on the virtualization cluster or somewhere completely separate? And then think about the application down. So going back to your developers or application users. So something like Tanzu observability. So it gives you full application level visibility in granular detail. That's probably the data that you're going to use to monitor the platform and scale as necessary, because what you're using something like Tanzu observability for is those kind of details of what is the performance and uptime and availability and metrics of my application itself. And then I'm going to map that to the business needs. So the business needs 99.9% uptime for my e-commerce website. My e-commerce website is a highly scalable distributed architecture based on Kubernetes and containers. So if one pod goes down, we don't care about that, because Kubernetes handles that and brings it back up, because it's a distributed scale architecture, as long as it doesn't affect the business need of the uptime of the e-commerce app of 99.9%, for example. So to dive down, thinking about things like scale and resource management. So obviously, the underlying physical platform, we can scale it out. We can add new hosts that then provide more resources for our virtual machines if we need to grow them, either whether it's scale up the virtual machines or scale them out. If using the VMware integrated technologies, we can scale resources at a logical grouping of a namespace. We can do this using the kubectl command to scale or auto scale deployments. And again, if you're using our Tanzu Kubernetes grid, again, we've got the same ability there to do that through our Tanzu CLI, or again, you can do that through the kubectl. And if you are deploying our services into a multi-cloud environment or a public cloud environment, you've also got the ability to do that through the command line as well. But really, the main thing here is to think about where that scale and resource management comes from. You've got, of course, the physical layer, and then you've got the virtual machine layer. So we need more resources, but how? So again, thinking more about scaling, we're going to that Kubernetes cluster. If it's at an application level, we can use things like the horizontal pod autoscaler, scale the number of pods in a replication controller deployment or rec set stateful set. We can do that based on observed CPU utilization out of the box, or using custom metric support or other application metrics, you can actually customize and define that yourself as well, and that's going to scale up your application. But then what happens once you've exhausted those resources inside of your Kubernetes cluster itself? Now, again, you could configure something like a cluster autoscaler. I hit 80% CPU and memory usage in my cluster as a whole, scale out and add an extra node. In a virtualization environment, that's fantastic because the cloud provider interface from VMware means that it can interface with your underlying virtualization structure and spin up a new virtual machine straight away. Brilliant. And it can do that based on if the pods fail to run because insufficient resources, or there's nodes in the cluster that are underutilized for an extended period, and we can scale that back down as well. One of the considerations for that, though, is cluster autoscaler needs to be configured at cluster deployment. So if you've got an existing cluster, you're not going to be able to configure that. And of course, we can always fail back and go to manual scaling of pods and cluster nodes, but that really takes away some of the advantages that we have with Kubernetes today. Okay, so where do we go from here? So we've kind of thought about design, we thought about the resources, we kind of want to push something out there. Most important thing to do next is benchmarking. Now, this was kind of the area where I was kind of really surprised in the Kubernetes world that this is not really well defined in the sense that there's quite a lot of options out there, but we're still kind of really early on, whereas in the virtualization world, it's quite easy nowadays to find a number of well-known, well-used and battle-worn tools out there that will help you understand the performance of your environment. But key thing here is to find a tool that you like, baseline your environment, then run your workloads, your test workloads, and then go back and run those same toolings again to see how much it differs from that baseline in the future as well. Of course, if you're doing this in production, you're not going to be able to run these same tools in production at times because some of these may, unfortunately topple over your environment, but at least you've got some metrics and understanding of what you're tracking against. So number of open source projects available today. There is one paid for product in here that I'll call out to you in a moment. For cluster management lifecycle, we've got Kbench, so it's a framework to benchmark to benchmark the control and data plane aspects of Kubernetes infrastructure. So thinking about how do I scale up my environment, what happens when I hammer the Kubernetes cluster API with thousands of requests in a second, how long does it start to take to respond to me, how long does it start to take to scale up resources and start to accept, through the admission controls to create new pods, for example. That's really important because, again, in your environment, not only are you going to be creating new things and have developers interacting in the environment, but you've probably got a number of other systems interacting, your monitoring systems, backup systems, and so forth as well. From storage point of view, we've got Kubester. So that was an open source tool produced by Caston, who I believe presented a couple of months ago. That helps you discover, validate, and evaluate your Kubernetes storage options that you've configured. We've got Kbench again, because it is a suite of tools. Really surprised in the networking space. I only actually found one tool which covers networking, and it actually uses iPerf under the hood if anyone's an old Linux user. Kbench again does that. So looking at that pod-to-pod communication, pod-to-pod across nodes and inter-node communication as well, so that you can see the configuration change, especially if you're looking at things like MTU design or testing different network plugins as well. And then obviously we get to the most important bit, so application build and load testing and failure testing. So VMware produced Weathervane. So this is an application level performance benchmark. It does a scale out distributed for application in your environment and kind of hammers your platform until it falls over. We've got K8's test suite, which is load testing on your application. KubeMonkey, so it takes the Chaos Monkey idea from Netflix and goes off and starts killing pods in your environment, so you can see how your application responds to that. And then we've got Powerful Seal. Same idea again, but it'll also affect your cluster nodes as well and take them offline to see how the cluster reacts and brings your pods, or if it's highly scalable rather than just killing individual pods in a namespace. And then security and compliance is also a massive thing. So Runecast, this is the one which is paid for, has Kubernetes Analyze, which focuses on CS benchmark. We've got Kube benchmark with security, again, looks at CS benchmarks. Got Project Sonoboy, which is a conformance test. But security is really key as well, because one, you need to make sure that your environment is secure. But secondly, we all know as well, at times implementing security or certain kind of baseline benchmarks for configuration as well can affect performance as well. So test performance, make the changes at security level, test performance again, see if that affects it as well, because you need to come to that happy medium within the environment. So I think we're nearly there on time. So I'm going to just run one of the very quick demos for everyone, because otherwise it's just a day full of slides. So I'm going to quickly look at Kubester for everyone. So Kubester, under the hood, it will check your CSI configuration, check that you've got, you can support CSI snapshots for the custom product for backup and restores. And one of the things that it will also do is it will run FIO for any of you that have used Linux for many years, and will build a pod, attach a persistent volume to it, and then run FIO into it to see the performance storage as well. So if we cut that out, very, very simple. You can use the old FIO test, and there's lots of examples online of this. So we can see here, we're going to do a sequential write. We can see the bandwidth size, how many jobs are run, how long we're going to run it for, the size of the file that we want to build inside of that. And then if I run this, so this will take about 60 seconds to run, and then it's going to give me that full FIO output as well. So this is just one of the tools that's out there. And whilst we're waiting for that, if any of you have got the questions up from earlier for the chat, then please, by all means, you can go to the paulev.com Cheryl Hung 278 and ask any questions that you've got in there whilst we wait for that to respond. "60 seconds always feels like a very, very long time when you're on a session like this and you know you're kind of running up on top of the hour to finish off."
Yeah, exactly. It's just always, you know, it's just like, well, it's 60 seconds, but for some reason it's always plus.
Yeah. Yeah, it's a shame, really. I had this practice earlier, and I'd actually get through everything in a little bit of a faster amount of time when I've been through the session before to show some of the other toolings as well. But the problem is with stuff like this, when you do it a couple of times, you start to digress or add extra information. So there we go. So we can see the FIO test finish. We can see the write IOPS. We can see the max, the minimum, the average. And again, we can start to kind of test and change things. This might be using a CSI to connect directly to storage. You might be then going through your vSphere storage and want to test different things like that. And then again, you've got the other options again for things like network testing, application testing, and so forth. So yeah, so we'll wrap that up here so that I can answer any questions or queries that come through. And I'm happy to kind of stay around just past the allotted time as well.
All righty. I think that the best way to do it will be to if you guys want to go to Rambly, let me it's here. If you want, so everybody who have any questions, I see that Danny and Dan, sorry, and I think Rodney was somewhere around there. So if you have any questions, please ask. And you know, and I would like to say that thank you very much for everybody who joined us today. It was a very pleasure to see you guys. Today it's I will probably see you at 5th of January. Yes, that 5th of January. I will see you on the next CI/CD meetup, and for all of you folks, Merry Christmas and nice holidays, and come back at I believe, at 5th. And again, after party on osho.com/r. There is a Rambly. There is a cool room when the cool kids hang out. Thank you very much, everybody.
Thank you.
And yeah, I'd like to say, have a good one.